Now let's learn about lists and how we can work using R on list. When we talk about vector, which we saw in previous examples, vector is a one-dimensional array, right? And it can hold elements only of same type. So we would say vector is more of one-dimensional. But when you talk about list is a generic vector that can contain objects of different types. So when you talk about, say for example, matrices can also hold elements of same type, but in matrices, it is a two-dimensional array. We will talk about matrices also, we will learn. So when you talk about lists, they can contain all kind of R objects. So you can have dates, you can have data frames, you can have vectors and many more. So in list, there is no coercion which is required, that is changing of data type. There is no loss of functionality, and lists do not follow any predefined structure. Now we can create lists using this list function as it is shown here. So you can create a variable and then assign a list to it, where you can be using either passing in a vector, or what you can do is you can simply create a list by using this list function. So let's see some example here. Now for that, what we can do is I can bring up my R Studio, where we can see an example on list and how it works. So when you talk about list, what you can do here is, let me close this one and this one. Yeah. So what we can do is we can basically say, for example, test, and I can basically give something here. So for example, I can say music tracks, and then I can say how many hundred of them, and I can say, let's give 100 as number, and then we can say how many of them got 5 stars, and I can do this. So I can check this, and this shows me all the objects or elements of this list, right? Now when we do this, what we are doing is we are creating a vector, right? And vector basically can have coercion depending on what are the elements which are passed, because whenever you use the C and you create a vector, it will only accept elements of the same type. So for example, if I do a class on test, it shows me here all the objects are of type character, right? And you can also use type of to check for our test variable, and it is basically having all the objects as character. Now how would you create a list? So what we can do is we can use a list function. So for example, let's again do a test here, but this time I'm interested in creating a list, and list can have objects of different types. So let's say music tracks, and then I can just give 100, and I can say with rating 5. And now if I look at my test, it shows me all the elements of your particular list. Here we see each element or each object with a double bracket, and we can see each element. Now what we can also do is we can use is list function, and then we can pass in test here to check what is it, and it is a list, right? So here we have created a list, but if for example we take the previous example where we were creating a vector, and if I would do a is list, it would show me false, right? So we just created a simple list, and we can also arrange labels, or we can use a name function to basically give names. So what I can do here is, let me create a list first. So I can do that like this. And now what I can do is I can do a name, and I can use a name function to this test. And then basically what I can do is I can pass labels. So here I can just give in some names here. So for example, I can say, let's give it a name, product. So say we are talking about product of a company, and then we can say here I can give count, and here I can give rating, and this is basically to give in names. So let's just give, there's some error here, let me just check this. So let's use this name function here, and what I'll do is I will basically use names, and now let's do a test. So that shows me the names what we have assigned to our list objects. Now we can always access the elements of or objects from a list using indices or even using double square. So for example, I have test here, and basically I can give something like this, which gives me based on the indices the position where you are accessing the elements of the list. So we can do this. What I can also do is we can specify names when creating a particular list. So for example, what I can also do is I can say product dot category, and now I can just give list function. So I would want to assign names while creating a list. So I can say, for example, product, and this would be, say, music tracks. Then I can give, say, for example, count, and count would be 100, and then ratings, and I can say 5, and now we can basically access this list which we have created. So what we have done here, unlike earlier when we created a list and then basically used names function to assign a name to it or each object, here while creating a list itself we passed in the names. So we can also do that. Now if you would want to basically display the list or compactly display structure of a list, we can always use the string function, and here I can pass in the name. So let's choose this one, and this is in a more compact way listing down the elements of your list. So list can be containing other lists also, and we can also do that. So for example, I create one more list. For example, I can say similar product, and here I can give a list again, and what I would want to do is I would want to say product equals, and I can say film, and then I can basically give a count, and then I can give ratings, say 4. And here what I've done is I have just created one more list. But my intention is not just to create a list, but I would want to add this to our existing list. So what we can do here is we can take our previous list, that is product.category, like what we did earlier. And now I intend to say list, and here I would want to say, for example, let's copy this, or we can just, so this is what we were doing when we were creating a list using product, giving the names while creating a list. And what I also want to do is here I will just say similar, and then pass in similar dot prod. So now if you look at our list, we have just added new elements. So this is one more way where we can create a list and we can basically add, or our list can have other lists. So when we talk about subsetting or extending list, so one of the main ways, as I said, to access a specific element or a subset, we use double brackets, and we can always do that. So for example, we take our prod.cat. If you use double brackets, then you're accessing a particular object. If we were creating a vector, we could just be using a subset by using the C function. Now, what we can also do is we can subset by names or even logicals. So what we can do here is we can take this product category, and if we have defined names, then in that case, what I can do is I can say I would be interested in music tracks, and this is the name we had given. So we can close this one and we can try accessing the elements here. So what's the name we had given? So no, it's not music tracks. That's the value. The name is product. So we do this and then we can access the elements. What we can also do is we can be subsetting based on logicals. So what we can do is we can basically just give something like this, and here we can pass in values. Something like this. And we missed a bracket. So that's also a way of pulling out the values. So you can be doing a subsetting using the names which you have assigned to objects within your list, or you can say names which you have assigned to the elements, or by using logicals. Now what we can also do is we can use the dollar function. Now if you see here, we are looking at the name and that is preceded by dollar. So we can always pull out the values from our list by giving the list name and then give a dollar symbol and then choose the name. For example, if I choose product, I can list the values here. I can be looking at, say, dollar and then choose a count. And this is also one way of accessing your elements from the list using your dollar symbol. Now, to add elements to a list, as I said, you can add a vector of names and that can be passed to your list. So these are different ways in which you can work with list, and then you can access the elements either using indices or using names or even using dollar symbol and pointing the right names. So this is one simple example of working with your list. Now one more, and now I can just do a Control L and I can clear that off. So your list, always remember, is a generic vector that can contain objects of different types. Now, when we talk about matrices, now matrix is a collection of data elements arranged in two-dimensional rectangular layout. So we can use matrix function to create a matrix as shown here. So matrix is two-dimensional. Now we already know that vector is one-dimensional array of data elements or a sequence of data elements. But when we talk about matrix, it's a collection of data elements that is two-dimensional, arranged in fixed number of rows and columns. So here you see that we are creating a matrix and we have specified the number of rows is 3, number of columns is 3, and we want it to be arranged by row where we have given the value as true. So always remember, matrix is two-dimensional and matrix can have only one atomic vector type, unlike your list. It's a natural extension of vector going from one dimension to two dimensions. So matrix actually needs a vector which contains values that you place in a matrix and at least one matrix dimension. So we can choose to specify the number of rows or number of columns when we are creating matrix. So let's see a quick example of working with matrix. So for example, I could just say matrix which will have values 1 to 6, and then I can basically give n row, and you can give a value to this one, and that's my matrix. Similarly, you could also be giving n columns. So I can just say n col, and I can choose this one and then pass in the value. So that's a matrix where R fills values column by column. Now, if you intend to fill up matrix in a row-wise fashion so that your values 1, 2, and 3 are in first row, then we have to just modify this in a little bit different way. So we have to say matrix 1:6, and row is 2, and then I can give by row. So you always have these helper functions which allow you to put out the values. So for example, I do this, and then I can do a control enter. So now if you see, you have the values 1, 2, and 3 in your first row. So when we pass a matrix function to a vector that is too short to fill up an entire matrix, then something different happens. We can have a look at this. So say you pass a vector containing value 1 to 3 to the matrix function, and say explicitly you want a matrix with 2 rows and 3 columns. How do we do that? So for example, I can say matrix, and here I can say 1:3. Now I can give n row, and then I can give the number of rows which we want is 2, and then I say n column, and this one I'll say 3. So I can do this, and here what I've done is I've given the values 1 to 3. I have said number of rows is 2 and your number of columns is 3. So here R fills the matrix column by column and simply repeats the vector. Now, if you want to fill using a 4-element vector in a 6-element matrix, in that case, obviously, R will generate a warning message. Now, apart from the simple matrix function which we are seeing, you also have some functions such as rbind and cbind, which R offers when you are working with matrices. So we can use those. So for example, I could say cbind, I could say 1:3, and then I can say 1:3, and that's my cbind, that is column bind, where I'm passing the values 1 to 3 and which are stacked in columns. I can also do rbind, and similarly we can be passing in the values. So I can say rbind, and that basically arranges the values row wise. So be creating a variable, for example, let's say n, and let me create a matrix here. So I'll say matrix. Now that will contain 1 to 6, and I can say by row, and then you can give value which is true, and then I can basically say the number of rows is going to be 2, and this is also fine. So let's look at the value of n here. So you basically created a matrix with 1 to 6. You arrange them row wise, and the number of rows what you have chosen is 2. So what we can also do is we can use rbind and we can add values to it. So for example, if I want to add values 7 to 9, what I can simply do is I can do a rbind. I can say I would want to edit my n and then pass in the values. So I can just do this, and this has basically appended or added values to existing matrix. So similarly, you could have done a column bind and you could have added values to your existing matrix. So for example, if I take this one and look at my n, and what I could do is I could do a cbind, and then I can basically take my n and then pass in values to this one. So let's say 10 and 11, and basically I've added 10 and 11 as a column to my existing matrix. So this is one simple way where you work with a matrix and you are appending the values either at a row level or at a column level. So let's also look at some other examples. So basically, if you would want to work with matrix one of the useful things would be naming the matrix. That is, in case of matrices, we can assign names to either the columns or the rows. If you don't do it, we see the default values here, which follows in numbering. But what we can also do is we can use two functions here. One is row names, or you can use column names. So these are the two functions which can be used. So for example, let's do a control L. Let's try to get our N. And this is what we are doing here. But what we would want to do is we would want to give them some names. So for example, I'll say row names, and then I will basically pass in a vector which has row names or vector which has column names. So what I can do here is I can say I would want to give row names to n, and then I basically give some value. So for example, let's say row 1, and then let's say row 2, and now I can look at my n, which has the row names assigned to my rows. Similarly, I could have also given column names. So all I need to do here is I need to say column 1, and then I will say column 2, and then I can be using column names. And let's look at this one. So what went wrong here? So we have three columns here. We forgot that. So we have to add one more column name, and then it should be fine. So now if you look at this one, we have just given row names and column names. So naming the columns or rows in your matrices can be very useful. Now, as the previous error says, there is also a function called dim names, and that's basically an argument of matrix function which can be used. So we could also do something like this. So for example, I have dim names. So let's have our n, and then what you can do is you can do a dim names, which you can then just create a list. And in this one, you can pass in a vector for row 1, and then vector for row 2. And what we can do here is once we have given this, let's give a comma here, and then give C, and then give your column names, which is column 1, column 2, and then basically column 3. And now if you just look at dim names, so you can just see that you have given some row names and column names, and this can be used basically to assign to your list. So if you try to store different objects in a matrix, what would happen? Coercion would take place, right? So for example, if I have X, and let's basically try to create a matrix which will have 1 to 8, and let's say the number of columns is going to be 2. So let's look at our X, and this has the values. Now what if I create, say, L, and then basically I will create a matrix which will be a matrix of letters. So let's say letters, and then here with letters I'll say 1:6. Now I would want to give the number of rows, and let's give it say 4, and let's say number of columns, and let's give it 3. And now let's look at the value of L. So it has letters, and X is having numbers. And what if we bind them together using C bind, which is for column wise binding? So for example, if I do a C bind and then pass in my X comma L, so if you see here, there is a coercion which has happened where everything is converted into characters. So you can always do a class and you can check. So this is a simple example of working with matrices. There are much more. You can do subsetting like what we saw in list, but that we can learn later. Now let's learn about data frames, and what is a data frame and how do you use R to work with data frame. Now, data frame is used to store the data in the form of a table. And for this, we have a function data.frame to create a data frame. So what we know already is that data sets are comprised of observations, or what we call as instances or variables. And we always have observations to which some variables are associated. For example, we can talk about data sets of say 5 people. Now let's look at the information here. Here we look at the body mass index, BMI, where we are using a data.frame function, and then we are passing in, say, gender. So we use the C function to pass in the values, and then you have height, and then you have weight and age. And these things then become the columns of your data frame. So for example, if we would want to work on creating a data frame for people, where let's say each person is an instance, and properties about each person such as name, age, child, or if the person has a child, would become the variables. So if we have such kind of information, we cannot easily store that in matrix or list. Now data frames can be used for such cases. Now, it's a fundamental data structure to store data sets, pretty similar to matrix as it has rows and columns. And here, rows correspond to observations. Now, here we can talk about an every individual or every person. Columns correspond to variables, that is properties for each person. Now, difference between your data frame and matrix is that data frames can contain elements of different data types. So for example, we can have one column being character, other being numeric, and yet another being logical or numeric. So restriction is that elements in one column should be of the same data type. Now, how do we work with data frames? Let's see some examples. So what we can do is we can bring up our R. So when we talk about data frames, usually we don't create data frames by ourselves. We import data from data sources such as CSV file or RDBMS or even your Excel or SPSS, and then we create data frames. Now, of course, R has ways to manually create data frames using data.frame function. So we can create 3 vectors first, and then we can pass in those vectors to create our data frame. So let's do that. So let's say name, and here I will use the assignment operator, which we have learned earlier. And then I'll use C, and then I can give some names here. So let's say John, and let's say Peter, let's say Patrick, and let's say Julie, and let's also give one more name. So let's say Bob. So this is the vector which we are creating, and we can check this is the vector which we have created. Now obviously you can do a class and you can check what is this, and that says it is a vector of character. Now similarly we can create one more vector which is age, and let's give some numbers here. So for example, let's say 28 and 30, 31, 38, 35, and these are the values for the age. So age is also created. Similarly, we can say if each person has children, so we can say children, and then I'll create one more vector, and here I'll give values which are logicals. I'm not going to give any numerics or character, but I'm using logicals here. So if a particular person has children or no. So let's have this vector created. And now we have 3 vectors, that is name, age, and children. And we can use this to create our data frame. So we can just call our data frame as df. And what we can do is we can use data dot frame function. And then what we can do is we can pass our vectors within this, such as name, age, children, and that should create my data frame. Let's have a look at this, and this shows me that the data frame is created. Now column names are inferred from variables which are passed to data.frame function. So the variables which we have passed to our data.frame function is name, age, and children, and those become the column headings for my data frame. Now what we could have also done is we could have created it in a different way. So I could have said df, and then I could have used my data.frame function, and in data.frame function I could have said name is going to be name, age would be age, and then I could say children could be children, and I could do this. And this is also one more way where I'm creating a data frame, and in this way we can now have rows of data frames like in matrix. So this is also one way of creating a data frame. To look into the data frame structure, we can always use str, and then we can pass our data frame, and this basically prints out similar to that of list. So we also need to know that under the hood data frame is a list, and in this case this is a list with 3 elements. So each list element is a vector of length phi corresponding to the number of observations. If we create data frame with vectors not of same length, we would get an error. Now here, when we look at our data frame, we know that name is a column. So name column, which is character, is actually a factor instead of character. To suppress this behavior, we can always use a property that is strings as factors equals false. So what I can do is I can do a data frame like this, use my data.frame function, and then basically we can pass in our vectors, that is name, age, and children. And then what I can do is I can say strings as factors and set this value to false. So if I do this, and now if I look at my data frame structure, sorry, yeah, now let's look at this one, and this one shows me that unlike your earlier one, now we are creating a data frame where our name would be containing characters. Earlier also by default it was showing as character. Usually if you, because this value by default is set to false, or it would have created characters or factors as we say. Now how do we do a subset and extend and sort data frames in R? So as we have learned so far in brief about your data frames, so data frame is somewhere like an intersection between matrices and lists. So if you would want to subset a data frame, we can always use the square brackets, and in that we can use the single square brackets which are from matrices, or we can use double square brackets from list, or we can also use the dollar symbol. So that all these things can be used to subset a data frame. So let's use our data frame which contains information about people. So we can select single element from our data frame. So here what we can do is we can just say df, and then I can use a single bracket, and I can just do a 3,2. So it would be good if we can first print the data frame, and that's my value. And now let's do a single bracket, and let's look at this one. So this tells me that we are using the row index first, which is number 3, which shows me that we would be going to the row number 3, and then we point or pass in our column index, that is number 2. So we could have done it in a different way also. So we could have done df and then give a row index and then give the column name which you are interested in looking at, and that also gives me the value. So just like matrices, we can choose to omit one of 2 indices to end up with entire row or entire column. And for example, if we would be interested in looking for information for Patrick, what I could have done is I could have just df3 comma, and this is showing me the entire row. Now always remember, whatever results we see here, that is giving me a data frame with a single observation, because there has to be a way to store different data types, and that's why the result is also a data frame. What we can also do is to get entire age column, we can just use our data frame, and then we can pass in the column name here like this, and that gives me just the column. Now here, the point to notice is result is a vector because columns contain elements of the same type. In previous example, we were seeing a row, and in that row was not a vector, it was a data frame because values were of different data types. Now subsetting a data frame that results in a data frame and contains multiple observations can also be done by doing something like this. For example, I will do df, and then I will say, let me get 3 comma 5, and then I can just say age and children, for example. So let's say age and children, and I can be pulling out the values in this way. So I could also be just getting the results in the age column if I'm interested in by just saying df, and here I can just pass in the column number, and that also gives me the age column. Now we know data frame is a list containing vectors of same length. This means we can use list syntax to select elements also, and what we can do is we can use our dollar symbol and then choose the column name, and this is also one way wherein you can pull out the values, or you can use double brackets as I mentioned earlier and pass in the column name. So that's also fine. Or you can give a column number, and that also would work. And in all these cases, result is a vector. Now with single brackets, you can still do it. Always remember, if you use single brackets, then that will result in a data frame. The result can be a data frame here, but what we are seeing here is a list which contains only age column having the data elements. So these are different ways in which you can do a subsetting of a data frame. Now using single brackets or double brackets can have serious consequences. So we need to always think about what we are dealing with and how are we handling it. Now what we can also do is we can extend our data frames. That is, we can add variables, we can add columns, that is adding variables, or we can add rows which are nothing but observations. So adding columns is like adding new elements to the list, and for which we can obviously use dollar or double brackets. Say for example, now this is my data frame, and if we would want to add height whose information is in a vector, so let's say height, let's create a vector here, and this one is what I would want to add for each person. So let me do this, and let me pass in some values here, and the last one something like this. So this is a vector created. Now what I can do is, so our data frame is called df, so we can say df dollar height, and then I will pass in this vector here. And now if I look at my data frame, you see the fourth column has been added, and that's my height column. Now what I can do is, I could have done it in a different way. Basically, if I had my data frame, I could have just done df double brackets and then give it a name, and then I could have passed my vector in this way. However, so this is also one way of doing it. We have already added the column, so we don't need to repeat the step. Now what we can also do is we can use a cbind function. And if you remember cbind, that is for column binding. So for example, let's create a weight vector now, and let's pass in some values here. So for example, let's say 75, 65, 54, 34, 78, and these are my values of weight. Now what I can do is I can just do a C bind and then pass in my data frame and then pass in this vector. And in this way, I'm just adding columns, or I'm extending my data frames by adding more columns to it. Now, obviously, if we can use C bind, then we can also use R bind to add new rows. So for R bind, creating a new vector won't work because we need to create a new data frame with one single observation. Remember, row will have values of different data types. So we cannot create a vector. We have to create a new data frame and then we can add it using R bind. So let me create a data frame here. For example, let's call data frame as Tom, and let's pass in some values here. So I will say data.frame function, and then let's give name. What we can do is we can give age, then we can give the logical value, then we can give, say, height, and since we have added weight, let's also add weight. And this is my data frame. Now we can use rbind function. So I can say rbind, and then I can pass in my data frame and this new data frame which we have created. And this tells me that the number of columns of arguments do not match. So we will have to check this one. So we have our data frame which has just height, so it does not have the weight. That was only as the result of C bind. So let's create this Tom again without weight, and now let's do a R bind, and let's again check what is the reason here. So this is height, and let me just check this. So to look at this, this is the error we were getting because I was creating a data frame with 4 columns, and then I was trying to add that to a data frame which had 3 columns. Now, yes, we had done a C bind, and C bind was showing us the 4th or 5th column, but the original data frame only had 3 columns. So what I did here was I did Tom, and then basically I created a data frame with 3 columns which matches with my original data frame which had 3 columns, and then I could use rbind to basically add one more row. So what we did was we used rbind, and rbind was used to add a new row to our data frame. Now, when it comes to sorting or ordering your data frame, say for example, we want to sort data frame by age. Now, how do we do that? So we could easily do sort df and then select our column, and we could just do a sorting. Now, if we do this, it is good, but not really what we need. Now, other clear way of doing that would be using ranks. So for example, if I do a ranks, and instead of doing a sort, I would use order and then basically pass in my column. So I would say df, and then I would use age. Now in this case, if I look at ranks, it shows me a vector of ranks with rank position of each element. Now if I do a df $age, it shows me the values, and if you look at the ranks, it will tell 21, or here the lowest value is your 28, and that's the lowest value, and that's why we see as rank as 1, and so on. We can look at the ranks. So what we can also do is we can just do a df and then basically use ranks, and we can just look at the result. So this shows data frame which is a ordered data frame now based on ranks. Now if we would want to do it in a descending order, what we could also do is we could do a df and then use order, and within order I will basically pass my data frame. I will choose my column, and then I could say decreasing equals true. And I could do this, and here this could show me the value. So it says undefined column names. So what I would have to check is what is my data frame here. So we have age, and then what we would have to do is we would have to select a particular column. So let's do that. And here I have just selected the column, and then there is a comma missing that was showing an error. So now we can have the data ordered in a descending way. So there are dozens of packages such as dplyr, data table, which can help you manipulate, filter, merge, and sort your data frames. So this is in brief about the data frames, working with data frames, subsetting them, and also sorting the data in your data frames. Now, one more important type of object in your R is vector, and that really helps us in various ways. So let's see how we work on vectors here. So to create a vector, we can use the C function and pass in the values. Those will be the objects or elements within the vector. And then you can look at the value of the vector or also at the class of it, which tells me the values are numeric. Now, in case of vector, all the values have to be of the same type or belong to the same class, we can say. So here we are creating a vector, looking at the value of it, and then looking at the class, which says the values passed in here are character. Similarly, we can do it for numerics, that is true, false, and then look at the value of this, and this class is logical. Now, what we can also do is we can print all the three vectors at once, and here we will use semicolon to separate two or more variables, and we can pull out the values of all the vectors which we see here. Now, what happens if we pass in the values which belong to different classes, or you can say different data types? So within a vector, if you do that, there is something called as coercion which takes place, which will convert all the values into one type, and in this case it has converted everything into character. Similarly, we can pass in values wherein we can pass logical and numeric, and in this case it's not going to go for character, it is going to convert everything into numeric. Now, if I had done this where I passed a character and numeric, and if you look at this, then it has converted everything into character. So character always takes a precedence if it is one of the values of vector and you have other values which are not characters, then in that case coercion will happen. There is one more way of creating a vector, and that is by providing a range to your C function. So we can do that here, wherein I said C1 colon 20, and then basically look at the value of vector 7. So it shows me all the values starting from 1 till 20. However, there is one more way. You can use the sequence function to do the same thing. Now, I could avoid the bracket, I could avoid the C function, and I can straight away pass a range, and that is also fine to create our vector starting from 1 ending at 25. So what if I want to create a vector with odd values between 1 to 20? Now in this case, I'm going to say how many values to skip or to jump. So I'm creating a variable called odd value. I'm using sequence function, and then to that I'm passing the beginning number, the ending number, and then the skip or the jump. And now if you look at the values, it shows me only the odd values. Well, we could have done the same thing to get even values, and that's not very complicated. So you can start from 2 and then you can do skip, wherein after 2 it basically gives you every second value. So we are looking at the even values, and this is how you can create a vector which is having odd or even values. Now, what if you want to create a vector with 10 odd values starting from 10? So you are basically giving a length. So here you can say from where you would want to start, what is your skip, and then the length of the vector, which tells me it gives me 10 odd values beginning from 20, or from 20 onwards, that is we take it from 21. Now, one of the requirements is always to name the values so that we can access the values either by indexing or by their name which have been passed to the value. So let's see that. So let's create a vector which is called temperature. So variable is temperature, pass in the values to this, look at the values of temperature. Now what we would want to do is we would want to assign these names to each value, which makes it more readable, more accessible. So I can use the names function, pass in my temperature as a vector to names function, and then assign the names to each value of temperature. Now, if you look at temperature, it shows me the names which have been assigned. Well, we could have done it in a different way. We could have created a vector of names, something like this. And then what I could have done is I could have created one more vector such as temperature. And instead of assigning values, we could have assigned the vector to our existing vector. So if you do this, so you're assigning the names vector to the temperature one, and now look at the values, it still does the same thing. So this is where you are assigning names to every value of your existing vector. Now there is one more way, and that is using your sequence. So here I'm creating a sequence which starts with 100, ends at 2020 with a skip of 20 values, or every jump would be 20 values. So let's do that. Use your names function on price, and then what I'm going to do is I'm going to use my paste 0 option, which takes P and then 1 to 7 as the values. So we know paste 0 basically skips the space, and we are going to assign those values to as names to price. And now let's look at our price. So that basically gives me the names as we desire. So these are some smarter ways of assigning names to every element or every object within your vector. Now, how do we perform some basic operations? Let's have a look. So let's create a vector passing in the values, and then you can simply do an addition on two vectors where each element is getting added to other element of the vector. You can subtract two vectors, that is element to element subtraction, element to element multiplication or division, and you can basically perform operations on the vectors. Now, how do we use some inbuilt basic math functions? And that's pretty easy. This is my vector. Now let's do a sum which sums up all the elements. Let's find out a standard deviation for all the values. Let's find out the variance for all the values here. Let's do a product of vector values, find the maximum or find the minimum value. So these are some basic inbuilt math functions which sometimes are useful in our data science or data analysis kind of activities. Now, one more requirement might be comparing the vectors using comparison operators. And this is where I create a vector 1, create a vector 2, and let's find out the values in V1 which are smaller than V2 values, and that gives me the logicals as the response, that is false, true, and false. Similarly, you can do V1 greater than V2, or you can say where V1 values are not equal to V2 or equal to V2. So these are some simple comparison examples. Now I can create a different vector, and then I can find out individually if the elements in the vector are lesser than 3 by just doing a V lesser than 3. So it compares each element with this. So you are actually using one scalar value to compare it with all the elements, and you can do that. It gives you the logicals. So you can also be doing slicing and indexing on vectors. And this is very much important when you're storing your data in vectors. How do you access them? So let's create a vector using sequence. Let's give it some names as we have seen in past. And let's look at our price one. So that tells me the name and the values. Now you can access the elements using indexing. So let's get the third element, and it shows me 590. Remember, the indexing here starts with 1, unlike other programming languages like Python, where indexing starts with 0. Now I can also get the third and fourth value by doing a 3:4. I can also specify the vector and say 1, 4, and that shows me the first and the fourth position, or second or sixth position. So this is one way where you are using indexing to access the elements. Similarly, I can give the names. Now that's where we see the benefit of giving names to every element. So I can use C function, pass in the name, and look at the value for that particular name, or selectively select different columns or different names. Or we can also use this square brackets wherein we pass the names. So sometimes it can also be useful to use logical positioning. That is, we would want to find out the logical position if the value exists, and we can do that, or using true and false and then look at the values. So there is one useful way where you can exclude a particular position. Might be that is an NA value, might be a value which you are not interested in, and that's where you will say -2, which will skip the P2 value, or -2 and -5, where we are skipping a P2 and P5, and we can exclude particular values from our vector. Now, how do we do a comparison operator on the values of vector? So you can just say price 1, and I would want all the values which are greater than 600, or you can assign this to a filter and then basically pass in the filter for your vector. So these are some simple basic operations which you can run using your R programming, where you would want to manipulate, where you would want to store some data and extract that data, use your different logical operators or other operators, and perform your basic easy computations. Now that we have seen some basic operations using R, let's look at some more operations when you're working with vectors, such as one of the common issues is handling the missing values. Now here we are assigning a vector to a variable order detail, and this one has a missing value. Now let's see how this is handled. And you see all the values in the vector are assigned. What you can also do is you can assign names, as we have seen earlier, by using the names function, and then look at the value of order detail. So you see the names, and these are your missing values which are also taken care. Now what we can also do is we can perform an operation on a particular vector which will be applied to all values of the vector. So for example, here I will just add a scalar value +5 to the elements in the vector, and that shows me number 5 has been added to each element or each object in the vector. Now, if you would want to work on two vectors, for example, to add two vectors, let's create a vector called new order, and then let's add it to order detail. Now, in this case, what we are doing is we have a vector which is from 5 to 10, and what we are doing is we are adding values to order detail. Now, our order detail earlier was 10, 20, 30, NA, 50, and 60. And what I have done is I have passed in a vector which is 5 and 10, and you're adding it to the elements. So 5 gets added to 10, and then your value 10 gets added to 20, and then you have again 5 which is added to 30. Now you cannot add in anything to a missing value, so that remains as it is. Then you add again 5 to 50, and then 10 is added to 60. So in this way you are adding two vectors which are not of same length, but you are adding these values. Now what I can also do is I can update the order by doing this. So I'm creating an update order, and now let's look at the value of update order. What does it show? So you are basically doing the same thing. So if you would want to work on a subset of vector, how do you do that? So here you are using some indexes. So I'm saying order detail, and this is my order detail. So let's take 1:2 and assign it to first two. So if we look at the value which is assigned to first two, we have just sliced and added a subset of vector to this one. And if I would want to take the length of order detail, it shows me the length here, which is 6 elements here, including the missing value also. What we can also do is we can do some more operations. So for example, from order detail, what I'm doing is I'm saying length minus 1 and then up to the length. So let's do this and let's see